There's a white powder that costs $1 and stops window condensation permanently. Not wipes it away every morning while mold grows in the corners you cannot reach. Not runs a dehumidifier that adds $40 to your electric bill every month. Stops it by absorbing the moisture that causes condensation before it ever reaches the glass, creating a microclimate around your windows where the dew point never triggers. One application on windowsills, frames, and between storm windows, and the morning fog, the water pooling on sills, the black mold creeping up the frames disappears, the windows stay clear, the wood stops rotting, the paint stops peeling. And because the powder does not evaporate or degrade, it continues working for months before needing replacement. Scandinavian homeowners have used this compound for winter window moisture control since the 1800s. The U.S. Department of Agriculture documented it in 1928 as the most cost-effective condensation prevention method for residential structures. It was standard home maintenance protocol taught in every household management guide through the 1950s. Then the home improvement industry realized they could generate recurring revenue from the problems this $1 powder prevents. The condensation damage repair market generates $4.8 billion annually. Window replacement, mold remediation, sill and frame repair, all downstream consequences of moisture that this powder eliminates at the source. A $1 powder that prevents window condensation permanently is not a product they can sell alongside $800 window replacements. It is a revenue stream they cannot survive. This is the story of the condensation stopper they buried. Welcome to Dr. Rayon Lab. Here is what causes window fog and why mechanical solutions fail. Condensation forms when warm, moisture-laden indoor air contacts cold window glass. The air at the glass surface cools below its dew point, the temperature at which water vapor condenses into liquid. Water droplets form, they run down the glass, pool on the sill, soak into wood, and create the damp environment where mold thrives. Dehumidifiers remove moisture from room air. This reduces condensation, but does not eliminate it. The window glass is still cold, the air near it still cools. Condensation still forms, just less severely. Meanwhile, the dehumidifier consumes electricity continuously, costs $200 and fails after 3 or 5 years. Insulation strips and window film create air gaps that reduce heat transfer, warming the interior glass surface. This raises the dew point threshold. But in cold climates, the temperature difference overwhelms even insulated windows. Condensation still forms during extreme cold snaps. The compound that actually solves the problem works through a completely different mechanism: desiccation. Hygroscopic materials absorb moisture directly from surrounding air. They do not reduce room humidity overall. They create a localized zone of low humidity directly around the window where condensation would otherwise form. The air contacting the glass is already too dry to condense. The most effective hygroscopic compound for home use is calcium chloride, a naturally occurring salt that absorbs water vapor aggressively. At moderate humidity, it absorbs 300% of its weight in water. In very humid conditions, even more. Place calcium chloride in a container near the window. It pulls moisture from the air before that moisture can condense on cold glass. The window stays dry, the sill stays dry, the frame stays dry. Mold cannot grow, wood does not rot, paint does not peel. But here's the mechanism the window industry hides. The absorbed moisture does not just disappear. It collects as liquid in the container. You empty it periodically. Every few weeks in high humidity, every few months in moderate conditions. The powder itself lasts indefinitely. Just replace or refresh when saturated. This chemistry has been documented since the 1800s. Scandinavian building manuals included calcium chloride window trays as standard winter preparation. The USDA published it as official recommendation in 1928. And the home improvement industry spent 50 years burying it under $800 window replacements. In Scandinavian countries, Sweden, Norway, Finland, winter condensation has been a structural threat for centuries. Indoor-outdoor temperature differentials of 50-70 degree mesh create extreme condensation conditions. Untreated window frames rot within 5 to 10 years. Traditional Scandinavian home maintenance through the 1800s and early 1900s included seasonal placement of hygroscopic salts in window trays. The compound, calcium chloride, or in some regions magnesium chloride, was placed in small containers on windowsills or between storm windows at the beginning of heating season. Trays were emptied periodically, windows stayed dry, frames lasted decades. The practice was documented in Swedish building maintenance texts from the 1880s as standard winter preparation, right alongside chimney cleaning and roof inspection. In 1928, the USDA Bureau of Home Economics published Farmer's Bulletin 1573, Home Care of Windows and Sills. The bulletin recommended, for windows subject to heavy condensation, place calcium chloride in shallow trays on sills or between sash. The compound absorbs moisture from the air layer contacting the glass, preventing dew formation. Replace when saturated. Material cost, approximately 5 cents per window per heating season. 5 cents per window per heating season. USDA official recommendation, published 1928. The bulletin was updated and reissued through the 1950s. It was standard reference in home economics curricula, agricultural extension offices, and public library home maintenance collections. Then, in 1965, the modern replacement window industry consolidated around vinyl and aluminum frame windows. Marketing positioned new windows as condensation-free compared to old wood models. The pitch: your windows are sweating because they are old. Replace them. This was technically incorrect. Condensation is caused by cold surface temperature meeting moist air, not by window age. Old windows with calcium chloride trays had zero condensation. New windows in humid homes still fog, but the marketing worked. By 1975, USDA Bulletin 1573 was out of print. Calcium chloride disappeared from consumer home maintenance guides. The compound was still available as ice melt and concrete accelerator, but with zero mention of window condensation application on labeling. The compound did not become less effective. It became commercially inconvenient. One $8 bag of calcium chloride treats every window in your home for multiple seasons. One $800 window replacement treats one opening and does not solve the humidity condition causing condensation. Think about the condensation in your home last winter. The windows coated with water every morning, wiping them down with towels, knowing the water is soaking into the wood frames, the black mold spots appearing in the corners, the ones you bleach away but keep coming back because you're treating the symptom, not the moisture causing it, the peeling paint on the lower sash, the soft wood in the sill where years of pooling water have started the rot process, the window that is harder to open every season because the frame is swelling from moisture absorption, the window replacement salesman in your living room. These windows are failing from moisture damage. We recommend full replacement, starting at $800 per window, financing available. All of this, the damaged wood, the mold, the $800 per opening quote, exists because the $1 solution was systematically removed from homeowner knowledge to protect the replacement window market. Here is exactly what to do. Placement and container choice determine effectiveness. What you need: calcium chloride, food grade or technical grade. Available as ice melt, calcium chloride formulation, not sodium chloride, from hardware stores, or as calcium chloride anhydrous from chemical suppliers. 1 pound bag for $8. Treats 6 taller 10 windows for entire winter season. Per window cost, under $1. Small containers, shallow dishes, jar lids, empty tuna cans. Must be wide and shallow, not tall and narrow. Large surface area maximizes moisture absorption. Windowsill or window frame space for container placement. For modern double pane windows, interior surface, place small open container of calcium chloride on each windowsill. Use approximately 2 to 3 tablespoons per standard window. Container should be shallow, more surface area, more absorption. Position near the glass, not at the sill front edge. The powder needs to dehumidify the air layer directly contacting the glass where condensation forms. Check containers weekly in high humidity conditions, monthly and moderate. The powder absorbs moisture and eventually becomes liquid or slurry. When container is mostly liquid, the powder is saturated. Dispose of liquid, do not pour on plants, it is salt solution. Add fresh powder. For older single pane or double hung windows between storm and interior sash, traditional method that works perfectly. Place small container of calcium chloride between the outer storm window and inner glass. This space is the most efficient location. It dehumidifies the air directly in contact with both cold outer glass and warmer inner glass. Condensation cannot form. For windows with removable storm panels, place container on sill between panes. Monitor monthly. For sealed double pane windows that are fogging between panes, unfortunately, calcium chloride cannot access the internal space. Fog between sealed panes indicates failed seal. The unit needs replacement. Calcium chloride prevents interior surface condensation, but cannot fix failed factory seals. For bathroom windows, high humidity, larger containers, 4 to 5 tablespoons calcium chloride. Check weekly. Bathroom windows experience extreme humidity spikes during showers. More powder ensures capacity to absorb without saturating quickly. For bay or bow windows, multiple glass surfaces, place containers on each window section sill. Large window areas require proportionally more powder. For sliding glass doors, place elongated tray or several small containers along the door track adjacent to the glass. Same principle. Dehumidify the air contacting the cold surface. Maintenance schedule. Early winter, place fresh powder in all window containers. Midwinter, January, check containers. Replace if saturated. In cold climates, this is peak condensation season. Late winter, March, April. As heating season ends and temperature differentials decrease, condensation becomes less severe. You can reduce number of containers or reduce powder quantity. Remove containers in spring when condensation stops occurring. Store any unused powder in sealed container. Calcium chloride absorbs moisture from the air and will slowly activate if left exposed. What you will observe: within hours of placing powder, visible moisture absorption begins. Powder may appear slightly damp or clumped as it captures ambient moisture. Within 1 to 2 days, window condensation noticeably reduces. Where droplets once formed, glass stays clear or shows minimal fogging in extreme cold. Within 1 week, windows should be consistently clear. The localized dehumidified air layer prevents condensation entirely. For windows with prior moisture damage, mold, peeling paint, softwood, condensation elimination arrests the damage progression. Mold cannot sustain without moisture. Wood rot cannot progress. Paint can be repaired once the frame stabilizes. For severe cases, very old windows or extremely humid homes may require larger containers or multiple containers per window. Start with standard amount, increase as needed. Combining calcium chloride with improved window insulation, weather stripping, storm windows, provides complementary benefit. Warmer glass and drier air working together to eliminate condensation. Cost analysis: 1 pound calcium chloride, $6. Treats 8 to 12 windows for 3 or 4 months depending on humidity. Per window cost for entire heating season: $0.50, $1.75. Dehumidifier: $200 purchase, plus $30, $50 monthly electricity, x 5 months, $350, $450 per heating season. Fails in 3 to 5 years requiring replacement. Window replacement, $401,000 per opening. Does not solve underlying humidity condition. New windows still fog if humidity is not addressed. Calcium chloride combined with source humidity control, bathroom, kitchen exhaust fans, provides complete solution at 1/100th the cost of window replacement. Historic Home Preservation Specialist, Boston, David Lindstrom, 25 years, restoring pre-1900 homes, posted on Preservation Forum 2019. Clients with original 1880s wood windows of extraordinary craftsmanship, curved moldings, hand-blown glass, irreplaceable. 3 window replacement companies told them these are failing from condensation damage. Replace with modern vinyl at $200 per opening. I showed them the calcium chloride method from 1928 USDA bulletin. We placed trays on every windowsill. Condensation stopped completely. Window frames dried out. Wood rot arrested. They still have their 140-year-old original windows, zero condensation, with a $6 bag of calcium chloride. The replacement industry, called hand-built 1880s, curved windows, failed when the failure was modern marketing erasing traditional maintenance. Scandinavian homeowners knew it in the 1800s, placing hygroscopic salts on windowsills as standard winter preparation documented in building maintenance texts alongside chimney sweeping and roof inspection. The USDA knew it in 1928, publishing Farmer's Bulletin 1573 recommending calcium chloride window trays at 5 cents per window per season as official government guidance for American homeowners. Home economics curricula knew it through the 1950s, teaching the next generation of homemakers the same moisture management methods their grandmothers used. David Lindstrom knows it now, saving irreplaceable 140-year-old windows from replacement while the industry calls handcrafted curved glass failed to sell vinyl replacements. $4.8 billion in condensation damage. Repair revenue depends on rotten window frames, mold remediation, and 800 per opening replacements for failed windows. Replacement window marketing depends on positioning new windows as condensation-free solution, while ignoring that condensation is humidity problem, not window age problem. $200 dehumidifier sales depend on treating whole room humidity with electricity-consuming mechanical devices rather than localized desiccation where condensation actually occurs. But calcium chloride chemistry does not care about replacement window profit margins. Hygroscopic absorption does not negotiate with dehumidifier retail markups. And a $6 bag of ice melt treats every window in your home, whether the window industry wants you to know it or not. If this changed how you look at your foggy windows, the $800 per opening replacement quote, or the $40 monthly dehumidifier electricity cost, subscribe to Dr. Rayan Lab and share this now. Every share cracks 60 years of marketing that repositioned traditional window maintenance as obsolete, while the replacement industry sold failing windows that were never failing, just missing the maintenance knowledge that was deliberately erased. Next vault. The $2 powder that eliminates basement dampness permanently by absorbing foundation moisture at the source, documented in building science since 1910, used in European construction codes, removed from U.S. building guides. The year foundation waterproofing became a $7.2 billion industry. Subscribe. The lab never closes. This is Dr. Rayan Lab. The science is yours.